Hello everyone. In this presentation, we are going to understand how to detect the human activity using the VEGA processor. So as we all know, VEGA processor is not going to detect the human activity. The 3-axis digital accelerometer, which is interfaced with the VEGA processor, is going to detect the human activity. Why VEGA processor projected here? Because it is an Indian chip, which is used to detect the human activity. That is why it is given as VEGA processor. So as we all know, ADXL345 is a digital accelerometer sensor which is interfaced with the Aries board, which contains CDAX VEGA processor, which has RISC-V open source core. And because it is human activity detection, it has to be wearable and it should be wireless. So to make this module as a wireless module, a UART to Bluetooth protocol converter module, which is HE05, which is being used in this work, where the received 3-axis reading from the 3-axis accelerometer is transmitted to the mobile phone through HE05 Bluetooth module. So this HE05 Bluetooth module is a protocol converter, as we know very well, which receives the UART data and it transmits the Bluetooth data. Then the data from the VEGA processor will go to the mobile phone. If the mobile phone needs to transmit something to the VEGA processor code, so the HE05 module receives the Bluetooth data and then it converts it to UART and then it give it to the Aries board. So it is a protocol converter. HE05 is a protocol converter which is used to convert the UART data into HE05 Bluetooth data, as we all know very well. So these three modules, the Aries board, that is VEGA processor in the Aries board, 3-axis accelerometer, and HE05 module combined together to detect the human activity, which is being discussed in detail in this video presentation. So this is what the HE05 Bluetooth module just now we have discussed. And as we all know, 3-axis accelerometer means, so one axis is pitch, another axis we call it as roll, another axis we call it as yaw. So roll, pitch and yaw, as we already discussed in the previous video. In the same playlist, the previous video which talks about the roll, pitch and yaw, which is the major portion in a car. So the roll moment, the pitch moment and yaw moment from the accelerometer is used to detect the activity of a human here. The concept remains same, the application varies as follows. So this is the circuit diagram which shows how the 3-axis accelerometer is interfaced with the VEGA processor. The protocol used here is I2C protocol. So where the serial data and serial clock signals are there. And HE05 module is interfaced with the VEGA processor through UART. Hence, TXD and RXD are the two bidirectional serial communication lines. As we all know, UART is bidirectional serial communication protocol and I2C is unidirectional serial communication protocol. And this Aries board, that means the VEGA processor, is capable of communicating with the peripherals through UART as well as in I2C protocol. That is also we have understood from this. So this is again the better clarity in the interfacing. So you can see the serial data and serial clock of 3-axis accelerometer is connected to the serial data and serial clock of the Aries board. And similarly, the TXD and RXD of the HE05 module is connected to the RXD and TXD of the VEGA processor based Aries board. So this is the pictorial diagram which represents how it works and which is interfaced in a breadboard where the 3-axis accelerometer, the HE05 Bluetooth module and the Aries board along with the power supply is being interfaced like this, as we know very well. And the reading which is observed in the mobile phone is shown here. So there is a Bluetooth terminal app. In this Bluetooth terminal app, the screenshot is being shown here. So it shows the time also. So at what time? In x-axis, what is the reading? In y-axis, what is the reading? In z-axis, what is the reading? And how much angle that we have turned. So that the angle that is with respect to the value, the angle is also being shown. So this is how we can receive the data from the 3-axis accelerometer to the mobile phone through Bluetooth module with the help of H05. So let us see, it is very interesting, right? So when we do any activity, let us say for example, we are doing the Uttanasana, which is we are forward bending as we see here. So if you look at the video, it is much more clear. So he is bending forward and standing. So once again, I play this. So he is bending forward and then handing. So in this, you are able to see here, there is a towel which contains the breadboard, power bank, Aries board, 3-axis accelerometer and HE05 Bluetooth module. So the interfacing of this Bluetooth module is very important. So as we see here, this complete setup is connected together and available as a wearable electronics here. It is something like he has weared the corresponding entire sensor in the stomach, exactly speaking. If so, if he is wearing in the stomach means he is bending forward. Because he is bending forward, which is related with the pitch. For example, when you apply the brake, we'll go and fall in the forward direction. So which is called as pitch. So with respect to the x-axis, we are moving forward, which is called as y value. So the y value is nothing but your orange color value as you see here. So when he bends forward and then he is returning back from forward movement, that is pitch is happening. So the y value has to change. So in this plot, you are able to see the orange color has a value which is close to 250. When he bends forward, the orange color value comes from 250 to minus 70 or something. And then again the value goes from minus 70 to again 250. So the sample, the x-axis is not time, x-axis is sample. So one sample is taken in 100 milliseconds. So say for example, there are 29 samples, which is nothing but 290 milliseconds, which is nothing but 2900 milliseconds, which is approximately 3 seconds. So the time taken for bending forward and then againing back to the same position is approximately 3 seconds. So the 3-second video. So 1 means 100 millisecond, 200 millisecond, 300 millisecond. So 10 means 1 second. 20 means 2 seconds. 30 means 3 seconds. So the 3-second plot of all the 3 axes is shown here, which is very clear. So when he is bending forward means there is a pitch activity is happening. So pitch is nothing but the y orange color waveform. The orange color waveform means the value of the sensor from the y axis moves from 250 to close to minus 70 and then from minus 70 to 234 as we see in this column. So these are all the values, x column, y column and z column. These are all the values which was read from the 3-axis accelerometer to the mobile phone, which is being plotted in the graph and that is being shown here for user friendliness. So the 5 samples are taken 5 times and then we are measuring the activity like this. Sample 2, the plot similarly goes from the orange color plot, which is y value, goes from 250 to again close to minus 100 and then again it is going back to 250 as we see here. So our interest is to look at only the pitch. So we are interested only in the orange color waveform, but there is no change in the roll. Hence the blue color waveform stands close to 0. So that is what in sample 2, the same thing, the activity here, and similarly sample 3, the activity here, and similarly the sample 4, the activity here, and similarly sample 5, the activity here. Now the forward bend continues. Let us see, continuously we are doing the exercise means we will do like this. Say for example, if you look at forward bend 1, forward bend 2. So continuously he is bending forward and standing back. So if you look at the orange color waveform, so it's again it is coming from 250 to close to 0 and then again back to 250 and again back to 0. This continues. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times he has done that activity, something like that we can do. So this is very important here, where the people, the exercise people, those who are doing means people, we can say camera can be used. But camera can be used means there is a privacy issue in many places. So wherever we are not able to use camera, or wherever we don't want camera, this kind of motion sensors or this kind of 3-axis accelerometers can be very well suitable for detecting the activity. This is one such sample that he is doing the forward bending 10 times, which is very clearly understood by these plots. So this is one use case. And similarly, there are few more things that we have tried, which is being discussed in the following video. So if the person is standing and then he is sitting in the chair, then what will be the pattern? So if you look at this, he is standing, and then for sitting, what will happen? We will move forward. We'll bend forward, and then we will sit, and then we'll bend backward. You can see from this video, as you know very well, he is bending forward, and after sitting, he is again sitting back. So bending forward means what? Again the same pitch. Bending forward means the same thing what we have discussed just right now. So it is the value, the orange color waveform only. We have to see the Y waveform. It is starting from 250 and goes up to 100, because it is not completely bending. When it is completely bending means the waveform goes up to 0 and sometimes to minus 100. He is bending slightly. If you see, he is standing slightly, he is bending. That's why the value goes from 250 to 100 only. And for bending, he is taking more time. And after sitting, he rests in short time. See, he bends slowly, and after sitting, suddenly he stands back. That is why there is a spike here. So from 100 to 250, the value goes up in short time when compared to bending forward and sitting. So as you know very well, the slope gradually decreases and suddenly it goes up means the standing person is sitting. Something like that we can understand. So this is sample 1, and similarly this is sample 2. So gradually decreasing and suddenly it increasing. Orange color waveform gradually decreasing and suddenly increasing, sample 3. And orange color waveform gradually decreasing and suddenly increasing, sample 4. Which is nothing but pitch in on context, which is pitch, which is used for identifying a person, standing person is sitting in the chair. So this is how it works. Sitting person is standing. So it's very interesting now. When the sitting person stands means he bends slightly forward and then he stands vertically. So if you look at this waveform, he bends slightly forward. So there's small spike here, and gradually he is standing up. You see, the bending action is there, and then while standing, he comes to the complete vertical position. So gradually, it is something like a tick mark, something like a tick mark. While standing, he bends quickly in the forward direction. Then slowly he stands up. That's why he bends quickly in the forward direction. It's quickly from 250 to 150, and then gradually he steadies. So gradually. So if it is something like a tick mark, then sitting person is standing. Something like that we can understand. So this is what we call it as data set. This is what we call it as data set. Data set for sitting position to standing position of a human being from the 3-axis accelerometer. That's very interesting, right? So we look at only the um, orange color waveform, which is Y value, because we look at only the pitch part. We look at only the pitch part, which is how it was. Now, the standing position, now we can compare. Standing position is sitting means gradually the Y value decreases and suddenly it increases. Sitting person is standing means suddenly the Y value decreases and gradually it increases. So the slope from 255 to 0, 100, slowly it goes means standing person is sitting. So the slope suddenly goes from 250 to 0 and then gradually it increases means sitting person is standing. So standing to sitting, inverted tick mark. Sitting to standing means original tick mark. This is how it works. So now we'll go to the next use case, stand to sleep position. So stand to sleep means what? A person standing, sitting in the cot, and then he sleeps. So what happens here? It's very interesting. A standing person is sitting in the chair means what was discussed so far will happen. Then, which is nothing but pitch. Then he sleeps in the cart means he do roll activity that you can understand. You see very clearly here. You can see standing person is sitting first, pitch is happening. Then again roll is happening. So that is very clearly understood from this plot. So standing person is sitting means what? This orange color waveform gradually decreases from 250 to 100, and then suddenly it goes from 100 to 250, which completes the standing person as sitting in the cart. For that, he sitting person is sleeping means what? He do the roll part. So the blue color waveform reflects the roll part. It's very interesting, right? So blue color waveform changes from 0 to minus 250, which because the sitting person is changing the 90 degree. He he rolls 90 degree. So this is vertical position means he rolls 90 degrees. So the value goes from 0 to minus 250. It's very interesting. So it is happening in sequence. Standing person have to sit first, then sitting person need to sleep. Standing person is sitting means pitch action is happening. So 250 to 100, and then again back from 100 to 50, the inverted tick mark, because standing person is sitting, followed by inverted tick mark if there is a step signal. So there is a 1 to 0 transition in the blue color signal justifies that sitting person is sleeping. It's very interesting. So the standing to sit activity can be understood by this orange color waveform. Sitting person is sleeping means sitting person to sleep position is understood by the blue waveform. So the blue waveform is nothing but roll, and the orange color waveform is nothing but pitch. So pitch followed by roll is nothing but standing person is sitting and then sitting person is sleeping. Similarly, the second sample, first orange color inverted tick, then blue color 1 to 0 transition. Blue color 1 to 0 transition means sitting person is sleeping. Orange color inverted tick mark means standing person is sitting. So it's very interesting, right? So the pitch and roll can be used in other way for standing person to sitting analysis and sitting person to sleeping person analysis. This is one interesting thing from the 3-axis accelerometer as we see here. So 5 samples was taken and the reading was taken and then it is plotted. And as we know very well, it's very simple. The x-axis is not the time, it is nothing but the sample at 100 millisecond interval. So here it is 53. What do you mean by 53? 53 samples at 100 milliseconds. That is 5,300 samples, which is nothing but 5,300 samples, which is nothing but it converted into time means so 5,300 milliseconds, which is 5 seconds approximately. So the person within 5 seconds, standing person will slept in the cart. So this is how you need to understand from this plot as well as this video clip. Now sleeping to stand. So the inversion action should take place. Here you can see the sleeping person is sitting first and then after that he stands up. So what happens so far is happening in the inverse. So first, because he is sleeping, the blue color waveform is in minus 250, and then sleeping person is sitting first. So it goes from minus 250 to 0. After that, sitting person is standing means there is a tick mark here in the orange color wave. So blue color waveform goes from minus 250 to 0, which is sleeping person is sitting. And then sitting person is standing means from the orange color waveform we are able to see sitting person is standing through the tick mark. So sleeping to sitting through the blue color waveform, and then sitting person standing through the right tick. So the two sequence concatenated. So the roll and pitch together, which is nothing but sleeping to sitting and then sleeping to sitting to standing. It's very interesting. So sample 1, sample 2, sample 3, sample 4, and then sample 5. So both, if you see comparison between two plots, standing person to sleep, that is standing person is sitting means the orange color waveform goes from 255 to the inverted tick mark. Standing person has sit in the cot, and then from sitting he goes to the sleep position, so blue color waveform goes from 0 to minus 255. And the sleeping person first sits means minus 255 to 0, and then the forward tick mark, so he stands up. It's very interesting. So sit to sleep, so only left side, sit to sleep in the left side, as we see here. There is, as we know it, the sit to sleep position means 1 to 0 transition, as we see here. This is one part of the same thing what we have discussed earlier, which is very interesting. Then sit to sleep in the other direction, sit to sleep in the other direction. So there is a transition from 0 to 1. This is very interesting. If he sleeps in the left, it is 1 to 0 to minus 255. If he sleeps in the other direction, if you see, he is sleeping in the other direction, so it goes from 1 to plus 255. In which direction he sleeps, that means the roll portion can be understood very clearly with this sample. So whether it is rolling left or whether it is rolling right with respect to 3-axis accelerometer, in our case, whether he is sleeping to the left of him or whether he is sleeping to the right of him. So here he is sleeping to the right in the samples. So the value, the blue color value depicts the sleeping nature because it is roll. So 0 to 255 notifies he is sleeping towards right. It's very interesting. Okay, the 5 samples was taken and both sit to sleep position left, so 1 to 0, sit to sleep position right, so 0 to 255. So it's very interesting, right? So if the blue color waveform goes from, if there is a falling edge, means is sleeping from towards left. If there is a rising edge in the blue color signal, means he is sleeping in the right direction. That is how it works. So the complete thing. So a standing person is sitting and then he sleep in the left. Then from the sleep position, he comes back to the sit position and then he stands. The complete cycle. It's very interesting, you see. Sitting, and then sitting person is sleeping to his left, and the sleeping person is again sitting, and then sitting person is again standing. From looking at the waveform, if you see, standing person is sitting, the orange color waveform goes from 255 to 0, and then sitting person is sleeping means blue color waveform goes from 0 to minus 255. So here he is sleeping. Sleeping person is sitting. The blue color waveform goes from minus 255 to 0, and then sitting person is standing means there is a tick mark in the orange color plot. So sitting person is standing. So the two dips, the inverted tick mark and the tick mark, denotes standing person is sitting and sitting person is standing. The transition from the falling edge, that is 0 to minus 255, says that he sleeps towards right, and then he wakes up from his bed to the, and he sits means this minus 255 is 0. It's fantastic. So the entire sequence can be measured by using the plot. This is how the activity. So the complete activity, stand to sit and then sit to sleep, sit to, and then sleep to sit and then sit to stand. All these activities can be monitored very clearly by looking at the pattern. So it's very interesting. So all these samples are data sets for us for all this activity which is being discussed. Very interesting. He slept in the left direction. So we can able to see the blue color waveform comes from 0 to minus 253. When he sleeps in the right direction, you can see the blue color waveform goes from 0 to plus 253. The same activity, standing to sitting, but sleeping in the right direction. So the blue color waveform, instead of coming from 0 to minus 253, it goes back from 0 to 250. but there is no change in the orange color waveform. So inverted tick for standing to sit, and then forward the forward tick for sitting to standing. But he is sleeping to his right, which the transition from 0 to plus 255 in the blue color waveform. It's very interesting. Rolling is towards right. It's very interesting. So the complete standing to sit and sitting to sleep, and then sleep to sit and sit to stand position from the left. Similarly from the right is very interesting. Both the plots are 100% similar except the blue color plot. So the blue color plot goes from 0 to minus 255 and then minus 255 to 0. If he sleeps, if he sleeps from sit position to sleep position to his left hand side. If he sleeps from sitting position to his right hand side, the blue color waveform goes from 0 to plus 255, and then this waveform it continues. So this is very interesting analysis for us to understand the activity of the human being. Particularly, activity of the human being means standing human being will sit normally, or sitting human being will stand. And similarly, sitting human will sleep to his left, or sitting human being will sleep to his right. So standing to sitting and sitting to standing is considered is map related with the pitch, and sitting person sleeping to his left or right is related with the roll. So the pitch and roll can be used to detect standing and sitting as well as sitting and sleeping more comfortably. This is the data sheet for the human activity as we discussed. So one very interesting point here that we will be discussing in the following videos. Here if you see in both the x-axis, right, here 1 2 there is 57, there is something like 57 and 50, approximately 55. 55 means 55 into 100 millisecond, 55 into 100 millisecond, 5500 milliseconds, which is nothing but 5.5 second. So a person takes approximately 5.5 seconds from standing position to sitting position, sitting position to sleep position, sleeping position to sitting position, sitting position to stand position. He takes 5.5 seconds to do all this activity. So standing position is to sitting position, approximately within this happens in 3 seconds. So standing position is sitting, sitting position is sitting, approximately happens in 3 seconds. When this happens, this plot happens in 1 second means he has fell down. Something like that, fall analysis kind of things can be done from this data, which is very interesting. So time axis is also very important. We'll talk about that in detail in the following video presentation. So to conclude, the 3-axis accelerometer can be used to detect the human activity as best as possible. That is being experimented in this experiment, and then which is being demonstrated as best as possible for your convenience. And as we know, Dinesh is doing more work on this direction. The person Dinesh is an experimental person here who wears all his sensor as a wearable electronics, and he himself is experimenting all these activities. And thank you for understanding this activity. We'll stop with this now.